Hello. I have no idea why there would be rain sound. Weird. I was looking through my assorted nonsense of old computer stuff that's kind of junk that I have acquired over the years from random transactions, and I noticed these in there, and they're actually kind of awesome. They're just clamshell pieces of plastic with foam inside that are cable management looms. These seem imminently 3D printable. So yeah, it'd be cool to make just like a generic OpenSCAD model for this at some point. Probably don't even need the foam. You can probably 3D print something that's malleable to go in there. Anyway, thought that was cool because I'm setting up something that some permanent cable routing stuff like this would be helpful, but I don't want to use just like 3 random ones. So, all right. Hello. It's raining coffee. Oh, well, I mean, that would both be great and probably hurt a lot. 90-degree ref point. Did anyone think to mention 2 green lasers above their head? Well, that wouldn't work because it needed to be in physical, practical space. I can't put the calipers up against a laser. Raining cold brew? I'd rather be dead. Coffee is meant to be warm or trash. Okay, there's the probes. All right, here's the deal. That is a DECWriter 2 down there, and it is sad. It no print, and I want it print. So, let me go over some of the stuff I've looked into. Not with that attitude, yeah. Maybe if I make the laser powerful enough, it can just burn through the calipers. All right, let's go over some of the stuff that I have been looking at and see. All right, so these are the schematics for the DECWriter 2. So half of you guys were looking at these while I was working on this last time, and I think I came up with a good analogy of kind of the problem with that. So I'm driving the car, all right, and the place we're going to is the Device Works diner, okay? We get to the diner and it's closed. And now I've got a bunch of people in the back seat with maps trying to tell me which way to drive, but they're all trying to go to different alternate restaurants instead. And that's the experience that I have when we get to something like the DECWriter and it doesn't work, and then everyone's calling out different things to try and test. It's one person's telling me turn right at this light, keep going straight, turn left, you know, it's all that stuff. So I just need to pull the car over and take a look at one of the maps myself at some point. So that's what I did a little bit here. I haven't spent a tremendous amount of time on this, so I don't have any suspect devices, but I have tried to document what we need to look at so that we can start to make some determinations. So here's what we know. This solenoid, number 3 here, goes all the way over here. Okay, analog navigation. All right, we got tangent time here, okay? The term analog is being abused now, and it's really starting to bother me. So actually, MB there, you just used the cool word that is the root of that, analogy. Analog is an instance of an analogy. It does not mean the opposite of digital, which is what people seem to think now analog means. And it's kind of bugging me because it's becoming this thing where people are calling like kids' wood block toys analog toys, which is just no. Digital means of the fingers. I could see that. I'm not 100% sure, but I could see that. But yeah, it's just, that's becoming very annoying. So no, a map, I mean, you could in theory say that a map is an analog of the real roads. You could say that. I don't feel like that is like a reasonable usage of the word, but it might be true. But it would not be that a paper map is an analog as opposed to Google Maps being digital. That's not how it works. So anyway, rant over. Old man yells at cloud. Okay, let's get back to work. Okay, this thing here, that's the solenoid that is running hot. Okay, it seems like DC current is passing through it because I think the way the solenoid works, I'm not 100% sure here. Someone can correct me on this. It's a magnetic device, and I believe that it only moves when a current fluctuation happens. So it will strike the paper and then immediately come back. I might be wrong on that, because when we have DC current pulling or pushing through it, I don't think it's poking out. Have you bought the paper schematic on eBay yet? Yes. Oh, cool. You ever wondered what a... Deck! Why do I need to know how to pack a truck full of these in the engineering manual? Yeah. There's two ways to. This is all of the engineering diagrams, I guess. Oh my gosh, that's amazing. Anyway, I do have those. I don't want to highlight or mark on those. What I've done is I've gone through to mark everything relevant to this signal. Okay. Well, not everything. The main stuff that seems to be power related. All right. So this, I don't know what it just did. I think it zoomed in like a bajillion amount and then, hold on. Oh man, that was great. What, engineers weren't documentation obsessed? Yeah. Oh man, if you don't do 40 DECWriter, so you can do it in your free time. Yeah, exactly. Anyway, all right. Solenoid 3, that's the one that's lay dead, all right? So it connects to connectors E2 and D2. Next page. Okay. So actually, let's go one more. All right. So over here, we have connector, it's actually on this side, D2, all right? E2 and all the others are shorted to ground through a coupling cap, but more correctly to positive 21 volts here, okay? So one side of the connector, E2, should be 21 volts positive. So we can test and confirm this is good, and we're going to today. I'm going to start making notes on these schematics. Then we can follow this trace back up over to these schematics. So this is where the logic signal comes in on connector J1, pin 32, and then it runs through R7, Q3, R6, Q2, Q1, and then goes off. Now, there is this weird setup here with these diodes, and my best guess is that this is a 60-volt shunt because this connects to, well, I guess the negative rail through there. It's a little weird. I thought it went to ground or something. But anyway, these are 15-volt Zener diodes, and I'm guessing that it's meant to, if the solenoid somehow backflows current because it shuts off the logic over here so the power can't go through or something. That's my best guess. That's a 60-volt shunt. So for the most part, we can ignore anything up here. I don't think that'll matter. Then we have down here, which I'm guessing is just debounce for this. I'm not 100% sure, but I don't think this is super critical. It's not involved in logic in any way, so none of that should matter. But we do have one of the test points coming to the gate drain source. Source? I can't remember. It's probably... Anyway, whatever. Base collector emitter. I know MOSFET from an NPS or BJT. Yeah, that's it. So that'll be base, probably, because no, that should be... Is that emitter? See, knowing that electrons flow backwards is the worst thing, because some things are named for that and some things aren't named for that. Okay, so emitter. It's named for conventional current, not... Oh, base is input. Yeah, sure. Turns itself off after capacitor charges. Oh, that would make sense. Okay. So charges that, these become the same reference. Okay, yeah, let's think about this. Current flows through here. It would have to get up to 60 volts. So is this like a charge pump type doodad thing? I don't know. And then these become the same reference and then this can't activate anymore. And then it bleeds. Well, I mean, that, like, I don't think that would bleed off because that's polar cap there. Anyway, well, all right. So this is not directly connected to power. But Q3 back here is, which is really confusing because Q1 is the one that seems like it would be. So this Q1 is a current sink. Actually, here, Q1 connects it to negative 21 volts. I should have led with that. So we have the... GIMP doesn't support multi-touch, and the touchpad does, and it's driving me nuts. Anyway, this connects to negative 21 volts. So we swing from positive 21 down to 21, negative 21. So 42 volt shift there. So if that charges and then stops it, that was, no, it doesn't, no. Not on there at least. Stop, get out of the panel editor. I think it does on the touchpad, but not, I mean, it's inconsistent about zooming or not. So I don't know. Like Q1 is output, yes, I know. What I was trying to get to the power. That's the I forgot. No power is delivered here. This is bottom side, so low side power switch. So we're activating the low side switch. I could see this being used to shut it off. So maybe we should look at this, or because actually, if Ben is correct and this should shut off if it's on, then that means that something in here has potentially failed. But that's not necessarily what's causing it to activate in the first place. By the way, somehow it just scrolled and the only thing I touched was a touchpad. Or it zoomed. Oh, wait. Somehow I'm on the zoom tool. Didn't even know the zoom tool was a thing. Okay, well that explains how I'm zooming. One or more driving transistors. Yeah, something like that. So it could be that these are shorted closed. So, all right. It's also the enable supplying power to Q3. Up here, yes, the buffered head enabled, but this is tied to all of these solenoids, so that should be fine. Unless this diode is weird somehow, but I don't think that could actually do anything. But yeah, that's tied to all of the solenoids, so it can't be that because we only have one bad one, so it has to be on the control side somehow. Okay. So I think I want to look up these transistors and then see what the pinout is and then measure from the base to the gate drain, no, base emitter collector, base to emitter on these to make sure that that's not like shorted and always providing power. Possibly, especially on Q2 there, that could be the most concerning one. So I think we should do that. And we can do that without power. So let me bring that up. 6531. Okay, let me see if I can find a data sheet for that. We also tested the control input and the logic is not sending a signal to turn anything on. I think we did that, but we're going to go ahead and restart everything because I was not looking at the map when we were doing that, and I want to write notes on the map as we go along. All right. 6513B transistor. $31B, not 13. Data sheet. And Mr. The No, turning it off and on direct, it always is hard off, hard on. Anyone's having issues with playback? It's unfortunate. I don't know that there's anything I can do about that. Oh, I hate the datasheet collection websites so much. You know, radiohobby.com sounds like it's going to be a lot less horrible. Yeah, that's better. Well, they're not well describing it, but I'm pretty sure it's opposite. So we have the curved side. I believe that it is 1, 2, 3. So from the flat side, left to right, I believe. And then it is, this is probably the standard transistor pinout. I just don't want to screw this up. And then emitter base collector. So we need to go from the base to the emitter on Q2. Guess I'll have to sub more before I can tell which keyboard doppelganger is at a glance. Oh, that's the real one. I should get it out of here, actually. Not that we're going to be doing anything, but it doesn't need to be up here right now. Ah. Caught on the ridiculously long HDMI cable. There we go. The real one is yellowed. Yeah. Well, I don't know. Actually, they kind of matched it in a weird way. It almost sort of matches the yellowed, but I have to look at it like just the right light. It's weird. Okay. I am going to grab a light from up here and a power supply. Which can almost kind of reach. Not really. Oh well, we'll come back to that in a little bit. Okay, Q2. From base to emitter, which is 1 to 2. Okay. Let's go look at that. Okay. Oh, that's so legible. There, let's just go with that. Did I fix the mic situation? Nope. All of the ISO. Yeah, can you see grain? All right. That's right. They're not labeled over here. Okay. That's why we need this one. Q2 is that. What's the problem with my digital mic? It's at home. Four kilo ohms. Okay, and then the other side, just for kicks, 4 kilo ohms. Okay. So that one looks good. So let's test the other one. $17K. $14K. Okay. Huh. So that, in theory, I think this should be directly wired to here. No. That's weird. Well, let me look at the schematic again. So the emitter, oh yeah, that was a base. I'm an idiot. Hold on. Left right emitter, base, emitter. So that's 296K. That would be would it be the collector or the emitter for the case on that? But I guess either way, it's not like dead shorted. So one side of the case should also be R1. And that's here. It'll either be something in 50 or, okay, it should be here. So that is 290K. So all three transistors are good. Or they're at least not shorted. Okay. Remember Q2 and Q3 are not the same type. One is NPN, the other is PNP. Yeah, but there's no, I just measured both sides. Okay, so those are not shorted. So I'm going to go into my thing here. And I'm just going to wish that the stupid GIMP tool wasn't idiotic. Why is it not drawing? Pencil tool. Seriously, if I somehow selected an area. There. So check, check, check. Those three seem good. Okay. I was gonna make coffee, got distracted, piled dirty dishes, revised my thoughts on the cap arrangement, middle transistor, had forgotten about the global head enable line. Make more sense to use pulse timing. The cap definitely smells. Timing related, this might be failsafe. Turn it off. Try to send too long of a pulse. Ah. Okay. Now I want to look with the oscilloscope and measure two traces at the same time. And I want to measure, let's go with Q2 and Q4. So that'll be this one and this one. I want to measure the emitter, or the base on both. Okay, I'm pretty sure I determined that's ground, but let me double check that. Maybe it was just this that was ground. So that's 100% ground. Okay. Sorry, cadmium plating, you gotta get a little chewed up to test. Actually, looking at it, it's a little chewed up all over. I wonder if I'm not the first person to be doing testing in this. Hey, Usagi. It would ring the bell, nothing else? Yes. We could paper advance, that was it. So the head solenoid is stuck. That's one problem. So I'm trying to determine where it is getting stuck. Just make sure this will actually turn on. Yep. Okay. Gosh, grief. I was wondering, where's my beam? Okay. Let's clear this. We have both channels on. Channel... I'm going to set these for 5 volts per division. And I'm going to set them to the center. Actually, I'll put channel 1 on the bottom towards the middle. I think that's supposed to be center, so I don't know why we're 5 volts up from that. You know what, I'm going to assume because it's off, it'll be like that. Okay, channel 2. Bring it there. Totally, no, you know, flip it so it's like what people would actually expect it to be. Channel 1's on top now. Channel 1 is the bad trace. You know, I'm going to set these to 10 volts per division. Let's just be real. Okay. All right, 25 microseconds is probably too much, although we're mostly just looking for a consistent change. All right, I'm going to turn it on. Okay, they both get pulled low. And there is no difference. So if I try to do a 1, we get nothing ever. Interesting. All right, and just to confirm, line feed does work. Okay. Probes in X10 mode, they should always be. But, you know, they weren't, because why would they be? Okay. Well, now that's a lot smaller of a change. One key did nothing now. What are we probing? The base of Q2 and Q3 to see if any logic is making it through. So it seems like not, which is weird. It's all right. I'm gonna check to see if the outside case of Q1 is negative 21 volts. So this should swing the outside case of the transistors from 21 to negative 21, depending on whether or not it's active. Voltage measurement. Okay. So I would expect this to be 21. No. Okay, weird. And this is also no. Well, how is that possible? Oh, because the head's not plugged in. I think I just realized I forgot to start the deck talk. Give me one moment. I have missed everything. Paul guy, that's what we're still working on.
Deck Talk is now online.
End of line.
Thrasher 976 has subscribed with Prime. They've subscribed for 5 months, currently on a 5-month streak.
End of line.
LUCKYBOP 77 has subscribed with Prime. They've subscribed for 10 months.
End of line.
Thrasher, thank you.
A tier 1 S up to Antonius. They have given 16 gift subs in the channel.
End of line.
Thrasher, thank you for the 5 months of Prime sub. Lucky Bob, thank you for the 10 months of Prime sub. And Swarp, thank you for the tier 1 gift sub there. All right. All right. Oh. Okay. And yeah, I'm down here, Diziak. All right. Now this should do some stuff. Let's see what happens. Okay, those both get pulled low. Now let me measure voltages on the cases of the transistors. So, normal one, 20 volts. Bad one, 18. Well, that's weird. 23. 18. So it's barely pulling anything? Interesting. So let me mark this. 18 volt, 23 volt. Okay. Yeah, it's semi-on, which is weird. So let me look at the base of Q4 and Q2. Oh, I am looking at the base of Q4 and Q2. I hate the X10. Why is it, like, bad? I'm going to set this to 2 volts and 2 volts. Okay. So they're getting pulled down. Did we determine that we couldn't figure out an X10 mode for this? Is that why I'm running them on X1? Because I think we couldn't figure out how to set this to X10 mode. Or I think we determined that it has a stupid sense ring that you need a resistor to short to, or it's not correct. Yeah, we're setting this back to X1. Screw it. That's what it is. Okay.
AARATAUS 82S subscribed at tier 1. They've subscribed for 36 months and says 3 years and you still let me in the front door. My plan is all coming together, :
End of line.
Carthouse, thank you.
At tier 1. They've subscribed for 40 months, currently on a 39-month streak.
End of line.
Carthouse, thank you for the tier 1 sub and for 36 months. And Moonwire, thank you for the tier 1 sub for 39. That's this many months. Or are we checking Q2, Q4, and not Q3, Q5, or Q1, Q16? So Q1 is this. And I don't want to remove this because that's going to suck a lot. It is not going to be possible for me to run the board outside of the chassis, so I can't probe the back side of that. I did check this. So this is the high side is at 18 volts DC. This is at 23 volts DC for the Q whatever it is. Yeah, 16. So I did check those. Yeah. Just do the X10 in your head. Keep the probes in X10 mode to save inputs on the scope from blowing up. Fine. So we were at some voltage. All right. So we're getting... Yeah, I wanted to see if the logic coming from here through the board is attempting to activate the transistor or not, and it does not seem that it is trying to activate it. Now, anyway, there was a thing I was going to test because I swear I can hear something up there moving, and I'm wondering if the pin is being pushed. So let me, find a piece of paper without getting up, because getting up sounds annoying. No, but I found a stick of SD RAM. All right, we're just gonna use the Sennheiser paper. Okay. Ah, it is being held. The pin is being held. Okay. So it's not an AC switch. The pin is being pushed.
Subscribed with Prime. They've subscribed for 42 months, currently on a 42-month streak.
End of line.
X1 probe should be banned from sale. Audio is not low level? Okay. Nakalak, thank you for the tier 1 sub for that, and 8 and 2, 30, 42 months. Thank you. Well, I guess I could also just hold them there, too. Okay, you're wanting... Hold on. So, Soggy, you were saying... I'm bringing up the schematic. Yeah, Q3, Q5, I assume? Yeah. So we can check that. I was just going back from the big transistors one at a time. So yeah, we can check Q3, Q5 next, because I have not yet done that. So these are on top of each other. Q5, trace 2, Q3, trace 1. Okay. And, oh, hello. That's 2. Is that going high? It's so hard to tell. Let me make sure this isn't AC coupled. I swear every time I check it's not AC coupled. DC, yeah. But it's all floaty like. But there's like negative voltages and stuff going through here too, so whatever. Okay, so channel 1 is on the bottom, which is Q3. We're on the base. That does not seem to jump up like channel 2 does. So it's staying low? Okay. So we have high and low voltage measurements for these. So that's going to 4 volts on Q5, but staying at 0 on Q1 or Q3. It's not one of them P&P nonsenses, is it? I think it might be. Hold on a moment. So So we're measuring this here, all right? And we're seeing low on channel 1, which is our bad solenoid, and we're seeing high on the other one. So I haven't looked at what the buffered head enable goes to. Goes down to this, which is... it's for like impossible to follow. Okay, I'm going to assume that this is high because it has to be for a source for that. So that is a pull up. So this is activating and pulling it low, I assume. Yeah, Q3 PNP, yeah. So that one is being activated or could potentially be bad. But why are we pulling so little current then? So it's R7 and R15 are before that. R15 is really hard to find. It's 15, right? Yeah, R15. Oh, it's way up here. R7, R15. Okay. So okay, yeah, so logic is going high to the... Wait, what? Did I just accidentally flip them? Yellow, I did accidentally flip them, okay. So it's backwards. So yes, it is activating... or not activating the other one, okay. So I can unplug the head now, I think. Yes. Uh-oh. Well, let's try this. I am unplugging the logic board. And now it does nothing. What are we probing here? It's backwards. But this is effectively as close to the digital input from the logic as we can get. So I'm probing the input from J1 to Q3 and Q5. And we're seeing Q3 stay low. And Q5 goes high, and they are P and P. So high would disable the solenoid. So Q3 is never going high, never disabling the solenoid. Which, in theory, means if I unplug this, it should fire all solenoids, right? Although it may not do the buffer head enabled whatever thing. Yeah, it's probably not, because they didn't fire them all. That might not be a problem, though. Take a look at the buffered head enable line. That's global gate. If that's low, then the logic input pins, which means the fault is further up the line from Q3. Those are two completely contradictory statements. All right, here's what I want to do. I want to measure with this isolated, the logic board not connected, whatever the other side of J1 connects to compare the inputs to see if it is on the logic board or if it's up here. So I need to look through the schematics a little bit more here. Because I don't have the logic board stuff down. We don't know currently whether the logic inputs should be valid. I'm going to ignore that statement because it feels meaningless. Okay. All right. Well, Ben, we don't know what the initialization procedure is. So the buffered head enable could be part of the initialization procedure where it pulls the head back to the left of the carriage. I don't know. Okay, so we don't want this one. So J1, this is just power. So we need, yeah, there's going to be more signals that are going through J1 there. So not this. Oh, stupid Gwenview will only do it when it's zoomed out all the way. Okay, that'll be helpful once we're there. But so there's our input connector and the weirdo labeling for the pins. So Ben, let me ask you about this with the buffer head enable. Well, that's just because Gwenview sucks, Digital Ice Age. That's not touchscreen lag. Here, if I do it with scroll and stuff on the touchpad, like, I can't even do it here. Hold, control, scroll. It's not touchscreen lag. It's, this image viewer is the worst thing on earth. I just don't know of a better one. Okay, what do we got here? I don't think I want any of that. Anyway, Ben, sometimes they put a master diagram with all the pins somewhere, but often not. All right. Ben, what are you wanting to find out about the buffer head enable? Because it, in my opinion, doesn't matter. Because the one pin is behaving erratically no matter what, whether the buffer head is working or not. So what is your thought process on that? Just whether there's any activity on it, I would expect it to be low at the moment, which means the logic input should be being ignored entirely. Okay, I think that's fair to check. We can look at that. So this would be the non-line side of D6. D6 is here. Okay. Yeah, Digital Usage, when I'm viewing a single image, Firefox is better for performance because it does canvas rendering instead of just like repositioning the entire image. But when you want to be able to scroll through multiple images, then there's like no good option. Okay. Non-stripe side of D6. And out of curiosity, what's up here? D5, I assume. I mean, that should just be good enough. Okay, so this is going to be channel 2 only here, and we're going to see what it does. Okay, I'm going to plug in logic. So it's low. It's not holding the paper now. Is the head plugged in? No, it's not. Good point. I wish this connector didn't suck so much. I think I'm gonna get cut up on the fiberglass every single time. Alright, now it's being held. And this is staying low. So... wait a minute. So buffer head enable is low. If I do that, then it won't be as easy to disconnect Hellencroft, and it's really tight. It's a... there's no good win, or no good solution on this that I can see. That's a good test, is enable pulse high. Nope. All right. I'm going to continue trying to follow the signal back. Okay. So I'm just going to look for something that's got, you know, J1 like that over there. Actually, you know what I should do? Let me go back here. I need J1, 32, or LL? MPC6? I don't know what that is. LL. Okay, here we go. So there's a 7404 inverting buffer, I think, here. And then that comes from pin 6 of the character ROM. So or pin 6 or, yeah, basically character ROMs. That's all that's connected to. That's curious. So they just address the character ROM and then feed that directly into the input. Okay. Open collector buffer. Oh, okay. Designator where that sheet signal is defined. Oh, that's smart. Okay, so we should look at E20. And it will be pins 3 and 4. Okay. So now we need to go all the way back to the one that shows the parts on the board. Not that one. This. E20. Okay. Probably next to the character ROM. Okay. So didn't it say it was a 7404? What I'm seeing here is a 7412 or 74123. So we were looking at not keyboard, not that, not that. This. Yeah, 7404. E20. 1, 2, 3 is completely different part, one shot. Buffer is inverting signal. Okay, that's what I thought. Yeah, I thought that the dot on the outside meant inverting, but it's been a while. So, yeah. Is there another one on here? E25. Okay, where's E25? Right next to E20. There has to be a different board rev. Yeah, this doesn't match mine. Never mind. Great. I don't see one. So they all have different part numbers. Yeah, it's a PCB silk screen. No, why would they do that? You're so funny. Yeah, so Usagi, I knew that there was a... Oh, it crashed. Cool. Beautiful. I knew there was a revision difference already, because there are two different versions of the schematic for the head stuff. So one is... Actually, I think I tried to pick all of the boards that matched, or the schematics here that matched mine. That's why we have a subset. So I guess we'll go back up to the full PCB, or PDF. All right, let the fun begin. Please full screen. There we go. Come on, where's the schematics? Here we go. All right, we're gonna see if we can find different versions. Schematic E74, E52, 701. You have page 292. This is why I don't use the PDFs, because you try to zoom in ocular and gone. So there we go. 7401. I didn't say 7401, by the way. It said 74123. Very last page. Okay. Hey, Cody. If we rerouted power, it would just blow up right now. That's the whole problem, is it's pulling too much power. Okay. Oh, I hate this thing. Okay, hold on. We stopped at 279. Ah, jeez. All right. Hold on. I'm just extracting more pages that contains that image. So yeah, Usagi, there's like 3 different revisions of the internals of this thing. The one I have here is an LA36DE, lacking RS-232. It is current loop only. There would be a little sub board that goes in here that converts like UART output port to be RS-232. Current loop is the only one that just has natively on board. So there are different configurations and different revisions. There's all sorts of variability with these, it turns out. Well, IC or IC is E20. Here. I can't easily show you, but there are 0 markings anywhere on this thing at all. So I have to look at that chip map in the page to see if the layout of the chips on here matches, and then I can look at the PDF schematics to see which one is what, because it's just chips. there's nothing. So I can't tell you what E25 is on here because there's no way to know. It doesn't even have the like coordinates on the sides. That would have been nice, but no. Presuming maybe what could be character ROMs? These two, maybe? I see a 7404 right here. So it could be this. That's close-ish to there. So I don't know. The failure mode, draw excess power, cook itself. Yes, that is exactly what's going on here as well. So this is a dot matrix printer, so it's got the head where the pins poke out to push the ribbon. One pin is permanently stuck out when it's on right now, and it's drawing too much current, and it's going to blow out the solenoid. So, I'm saying there is not a grid row. I don't know. Since they're naming transistors up on the logic, the power driver board, Q, I don't think that the designators are grid-based. Because the capacitors are also C. In the one schematic that I looked at. So, again, I don't think that there's a coordinate system. I'm going to guess that that one is it, but I don't know. I'm trying to make a grid from nothing, yeah. Yeah, no, unfortunately there's not. 248 is chip map, or 284? Okay, let's look at that. Alright, I got my extracted pages. So that was E28. Yes, this matches. This seems to be 3 caps there. Check, check, check. Yep, pen circles drawn on the board. Yep. Okay, I think that is... Yeah, this one definitely seems to match better. Okay, real quick like, I'm just gonna grab this and put it in here and open with GIMP and save. Boom. Okay, that's getting added to our collection of working pages. Certainly looks grid-like. It's also a common thing that older boards have a grid. I think the Data Generals did, didn't they? Okay, I'm going to go back to 284 and just look around it, see if we can find the match. Oh, the schematic was 292, wasn't it? So we want E52. Okay, and it's a 401, or 7401 this time. Okay, so I'm going to copy that. Okay, open with GIMP. All right, let's make some markings first. Yeah, Ben, that was what I was figuring. Okay. So, new layer. Boom. All right, fun little quick thing for everyone here. All right. So let's say you want to annotate a schematic in GIMP. Okay. What's the best way to do that? Well, first off, make yourself a brand spanking new layer, all right? And in that layer, you can draw. Whee! Drawing! It's so great. But what happens when you draw is you overlay stuff, and that kind of sucks because you can't see what's under it. So if you want to draw big fat traces to highlight something, you can't do it. So what you do is you set your opacity to 50%. Now you can see through it, but you're still covering stuff, which kind of sucks. So then you go to darken only as your mode, and bam, Now your highlighted lines are underneath what you are drawing. So that's how I prefer to do my highlighting, so that I can do it all without having to worry. Okay, so were we LL for the schematic? Yes, LL.
Bush subscribed at tier 1. They've subscribed for 31 months. And says I am suitably impressed.
End of line.
MQ Bush, thank you for the tier 1 sub and for 31 months. I appreciate that. Centurion definitely used a lot of grids of their boards, made reverse engineering less painful. Yeah, I can see that. Okay, so we need E47. And then, why are these like AND gates or whatever? And why do there's the input. N prim H, I mean, that one's probably always active, so I'm not going to worry about that for our use case. Okay, so we need to pin 8, and then that'll go off to these. Okay. This is where our logic goes. And it would be almost impossible for it to be anything past this point, because those are the character ROMs. We would be getting more pins stuck. Like it can't, I don't think it can even end or go past that. So it's basically got to be this chip right here that's bad. I mean, that directly connects to the logic board. So I'm guessing that we have a dead output on that. So E47. We need to find that. So we got J1 right here. Now let's make our new layer. 50%. Darken only. Okay. So E47. 27. Wait, why are they like a million miles away? Yeah, it's right here. Dude, why wouldn't you put the thing that directly connects to the output right next to the output? Yeah, so it goes on a big old long trip to get over there. Welcome to Deck Engineering. Yeah, chase signals all over. Oh, man, Deck love to do that. Lovely. E52 is next to it? All right. Well, I don't think we need E52 because that pin, I don't think it's driven by that ever. But yeah, that is good confirmation. Okay, so we need 8 and 10. These signals should be inverted. And it was being driven low, and we have a 5 volt, or we have a pull-up resistor here. Where's R110, actually? It just takes a detour right there. It's like, wait a minute, hold on, I need to use a restroom, and it pulls off to the side of the road for a second. Okay, so that's our pull-up resistor. Yeah, there's a giant bus of resistors on a trace there. Just remember, you're a field service engineer, therefore Deck hates you with undying passion. Yeah. Yeah, I know, that's why I was commenting it was an AND gate, but I assume it's going to be active, but let's just check the other ones first. Okay, 8 and 9 on E47. So, over here, oh, that's curious. Why are my ROMs different? I'm gonna guess this ROM's dead. That's my guess. Dump them and find out? I don't know, that sounds like work. There are a photo of the ROM chips in Discord. Someone made custom character ROMs for international characters? I don't know. It was for a state school, so I don't think so. Alright. So it's that one, which is 7401, okay. And we want that. Eight and 9. So 1, 2, 3, 4, 5, 6, 7. Why does 8 also go to a resistor that's over here? Okay, so that's got to be R47. Oh, that's way easier to clip onto. Let me make sure. It is. Okay. Yeah, I would have guessed that that one was the original one, because there's one over here that's soldered to the board. Okay, that was 8, and then 10. Ugh. Oh, wait. If only someone invented a thing to make this easier. Oh, yeah, they did. Chip clips! Alright, so it should be 8, 9, 10. I'm going to standardize to using the chip clips. Kind of for the brighter, more visible activity indicator that moved? I don't know. I'm not sure what you're talking about. Why am I getting notified? Okay. Okay, look over everything. 1, 2, 3, 4, 5, 6, 7. Wait. That was a DIP 16 clip on a DIP 14 chip, so I was off by 1. Okay, good thing I checked. All right. Let's see what happens when we turn it on. We should have an inverted output, essentially. And I think it should be high. This is the input, this is the output. All right, here we go. Okay. So bottom was high. What? Well, that's not right. How is that possible? Come on, boot, you slow thing. Beep, beep, beep. Here to... No, no, it's one of these. Okay, confirmed there. And then there. Okay, so this output goes here. That's the second channel. You can unplug the head now? Hold on. You want the output to be high, meaning you don't want both inputs to be high. Any other combination? Hold on. Input is low. Output is high. It took too long to go from the other side to here. Now I forgot what we learned. Okay, hold on. I'm marking this as high. Oh gosh. And the input was low. Okay, confirm. Red is pin 8 is set. Wait. Is input. Wait a minute. Pin 8 input. I got these backwards. Wait a minute. It's inverting correctly. We have a stuck pin on our EEPROM. The EEPROM is bad. Is that what it is? Because our output was low. Let me reconfirm this one more time. Yellow is on pin 10, which is the output, which is the higher channel. Okay. Output low, input high. Inverting working. The input being high means that we are getting data from our chip, I think. We also have the pull-up resistor. Yeah, now the answer, or the question is, which chip is doing it? I think I'm safe pulling the chips and running it, right? The ROMs. Oh my gosh. Standing. Holy moly. Both inputs are high. The output will be low. You don't know that you check. Oh, you check pin 9. Yep. Wait. Wait. You got two inputs, and if both inputs are high, the output will be pulled low. Turning Q3 on. If either input is low, let me. What do you? Both inputs to the NAND? Well, okay, hold on. The output is low. It's tied high with a resistor. But if this was the one that was activating it, then wouldn't all pins be activated on the head? Here's the thing. I don't think we should ever see this be high right now, because I'm not sending it a character. Right? Let me check pin 12. Just for my own sanity here. Okay, it's going to be the bottom channel. 8, 9, 10, 11, 12. It is low. Yeah, only 2 highs can make it go low. So we are getting a signal here. Usagi, what I'm saying is that this input, the other input does not matter. This input being high is on its own bad. Because it's coming directly from the character ROM, which we're not using currently. So that input being high means that this is the problem. It matters when we go to use it, but we're not currently trying to use it. So right now, input 12 here on this one is currently low, because we're not using the character ROM and that part's working. I mean, I can measure pin 9. It's trivial. Here, I'll do it. Bottom is pin 9. Here we go. It is high. Now, for completeness, pin 11, also high, because they're chained. I'm saying here, I need not pull both ROMs. I need to pull one ROM at a time. So one of the ROMs, because the ROMs have a tied output going into this, one of the ROMs is probably erroneously outputting all the time. That's my speculation here. So we could measure pin 6 on one of the ROMs, but they're tied, so we can't tell. So I need to pull one ROM and then see what it does. The other ROM, the ROM that's good, should pull it low. It's going to observe the machine isn't even finishing initializations. Who knows? Global head enable is inserted. No attributes matter. Why is the solenoid being engaged? We're probably going to dump the ROMs to check them, I guess. Although, I have no idea what that... I think Fairchild ROM is, and I think this time I'm right, and it's not the Fujitsu logo or whatever. Yeah, I think those are two viable possibilities, and I think since one of the ROMs is different, it's weird. BK, they are... I think it's open collector. So when these are off, they pull the signal low. They don't output data. They sync the signal when there's nothing there. But here's what I'm going to do. I'm going to pull one ROM, turn it on, see what it does. Then I'm going to put it back, then I'm going to pull the other ROM if we don't get a change in behavior. Okay, well, first let me observe high input, low output. Just real quick. Red input, high, okay, low. Okay, confirmed. All right. I'm pulling the older ROM, the probably older ROM, the gold ceramic one. Because that's one, if I was going to speculate which one is bad, I would guess that one. Okay, turning it on. Same behavior. Putting the ROM back. It has all legs. Just throwing that out there. All right, pulling the Fairchild, which is really, really snug up against that cap. Wow, someone didn't think this through. All legs intact. And same behavior. I've been touching the grounding strap over here before pulling stuff, so it's fine. I'm not moving, so I'm not generating ESD. You know, PC Magus, is actually not impossible, both are bad. It would be... I think it would be unlikely something would travel back through from the head, maybe, as like an ESD thing all the way back there. I don't know how both inputs would be killed. That doesn't make sense to me. It is the original part? Okay. Well, Usagi, when these are logic low, they should be syncing the current, right? Because they are open collector. So it should be even one of them, because they are tied to the same pull-up right here, should be able to pull the signal low. So that was why I didn't pull both at once. I was leaving one in so that it could pull the signal low. But that didn't happen. The UART is nowhere near close to this part of the circuit, so it can't be that. Well, I mean, physically it's close, but, you know. There are these jumper bodge wires over here that I don't like. Saying that removing the ROM, you're not testing the inputs anymore. What do you mean by inputs? Polling ROMs means the pull-up helps pull the input to the NAND high. No, no. that's why, again, yes, that's why I pulled one at a time. So these are joined. Both are connected to the input. We have one pull-up resistor right here. So if these are open collector, either one of them are able of pulling down the signal. So if this one is outputting high and this one is outputting low, because this one is open collector, it will pull the signal down. Because this doesn't actually output anything when it's output high. So if I leave one of these in here and it should be outputting low, it would still pull down. I'm pretty sure open collector is the only way you could do this setup. Tri-state, not open collector. But it's still the same concept. They should sync the current when low, and then basically be inactive when they're high, right? So pulling one at a time should have had this go low somewhere. If I pulled them both, it should definitely 100% be high. But results are it's not the ROMs. Usagi, I am working off of the assumption that all outputs should be low to disable the output from the NAND, because we are in the initialization process and we don't want a pin on the solenoid extended and dragging across the platen. On that, here's a question. If anyone wants to go look up directions to a restaurant for me, is there possibly something in the power board up here, maybe, or maybe the logic board, I don't know, where if a pin is active, it will not move the carriage? Because again, you wouldn't want to drag a pin. Because having that one pin active could be preventing the thing moving. Now I'm just making that up out of thin air, but I feel like that wouldn't be the worst safety mechanism. If it's high, the ROMs are inactive. Test point 6, E56. Okay, hold on. It's initialization. The ROM shouldn't matter at all. Well, the ROM shouldn't be doing anything during initialization. My premise for checking the ROMs is that one of the ROMs was bad. So that's why I was checking the ROMs. Now, don't trace it back yet, Ben. I have a feeling I'm about to go sit in front of the real computer for a while because using the Surface sucks. It's pin 23 on both ROMs. For the enable thing, how many pins are these? Hold on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, it's going to be high. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Okay, so I need to go. You know, I'm going to do this one. Okay, this is pin 23. It's going to be the bottom trace. Low. Okay, I don't remember what that is. Hellencroft, I'm not sure if they're fully in parallel. I feel like they probably have something different, but I don't know. Yeah, I don't know what low means, because you're giving me turn-by-turn directions now, and I don't understand the map of where we're going. All right. Yeah, Ben, that's why we're going to stop for a second and fully reset. Reassess everything that we've tested. Pin 23... Oh, never mind. Hold on.
FORTEXMP 6801 SICHEER 200. It's my birthday today. I'm 19 and out.
End of line.
Well, Vortex, thank you for the 200 bits, and happy birthday. Okay. Let me turn off the scope. There's no reason to leave it on right now. We're going to go do some planning. Ugh. This. Okay. So one moment, I need to upload the things that I have documented to the server. Poot, I don't know. That's one of the things that I need to look up before we continue. So I'm just gonna sneaker net this with a flash drive. Let me put this in the charging dock. It might even charge. I don't know. This dock is bad. All right. We're going to go over everything that we've looked at so far. So that we can all be on the same page. We'll take notes on the schematic. Okay. So our first problem is this solenoid is stuck. That is a horrible font and horrible everything about it. Bold. Bigger. There. Okay. That is the problem that we are working backwards from, okay? There's a secondary problem with this, in that the carriage never initializes, but we don't know exactly what that is. So there is the potential for the encoder to be dirty and it tries to move it and it doesn't. I don't know. I would think that it would move it and then never see motion or something. I don't know. We haven't looked at this. So I'm going to go ahead and mark this as kind of an unknown because we haven't checked this yet. So this whole area. Why can't I draw? Oh, it's super faint. Why? Because it's size 1 pixel. Jump! Okay. Okay. Now, trackball's not my friend. Hold on. I don't think anybody likes drawing with a trackball. This is question mark because we don't know if it's actually working or not. But this is not our known problem. This is a big known problem. So we took that. This connects to one side of the solenoid. The other side connects to a power supply. So we have checked this trace here. It comes down to 18 volts. A nominal one is 23 volts. So it's cutting paths with a trackball count? Trackball count? I don't know. Okay, this 60 volt shunt shouldn't matter. We checked that this one is working. Now I believe... I forgot what we measured this at. Because again, we did too many things. So let's skip ahead for now. We got to this, and we measured the output of this being low. This was also high. If you're asking, did we do X, assume no, or that I don't have the results. So, and don't assume that I'm about to go measure it. Okay, this was also high, if I remember correctly. So, high. Then we individually removed ROMs and saw no change in high state, which is ridiculously confusing. Yeah, NAND good. Sure. Let's just checkbox. Checkbox. NAND good. So these, confusing. Don't know what's going on there. Yeah, nothing to figure out from that. Okay. So we could continue to follow this higher up by looking at the ASCII bus. Here, one of these is the correct layer. There we go. So we could check this to see if we're getting data, but I don't think that that's correct. I don't think we should do that. So Ben, I don't think that that's really valid. So print head solenoids, I'm going to assume that 3 is probably third up from the bottom or third down from the top. It's in the middle. But it shouldn't be active no matter what at this stage. Like, it just shouldn't be active. So I can't imagine that we're getting valid data from this. You know, that's true. We've never seen... Hold on. We've never seen this be high, ever. This is not necessarily validated. It could still be this. Even though this is logically behaving, we don't know that this isn't necessarily the problem. MB, we could do that. So I want to, let's go back to here. Oddities. Pin stuck. Carriage not homing. Assumptions. Pin should not logically be active during carriage home. All right, here's another question. We kind of stepped over this as we were going up to the logic chain. Why is this only 18 volts? It should be pulled down to 21. This is, what, 0.5 ohms here? This should be a pretty strong tie to negative 21 volts. The opposite side, E2 here, is directly to 21 volts. Some of you are saying then that 18 volts would be nominal active voltage. I don't remember what we saw in buffer head enable. I'm going to go do a couple more targeted measurements right now, just one at a time, so that we can have these. Like, I don't remember what this... I hate GIMP. This. I don't remember what this was. I don't remember what this was. I don't care what we think we saw. I'm going to go remeasure them right now. Okay. So I want non-stripe side of D6. Head is connected. Effectively 0 volts, 0.1 volts. Okay. Now let's measure this. R7, basically either side or base of Q3. Well, let's measure base of Q3. Negative 22. What? That's Q2, not Q3. Still, that's kind of weird for a Q2 base. Mr. Oscilloscope, did you mislead us? Hold on. That's the COM port. That's the voltage port. Negative 22. So yes, it's tied to that. Okay, so maybe that is acceptable. Yeah, okay, I got it. So Q5 is 5 on the base. Whatever's to the right of Q5, I think Q4 is negative 24. I think I have that right. Yeah, Q5 was 5. And then this was negative 24. So let's measure Q3 properly this time. .1 versus 5. So again, Q3 base 0.1 as opposed to 5, but pulling that low would allow current to pass through, I think, and we see low over here because this is the same as this. Hold on, you're saying this should be off? Isn't this? Hold on. Yeah, I can measure R2. Not going to be my favorite thing to measure, though. $1.5. I am not seeing any problems in this whole setup. I don't even see where R4 is. Oh, there. Playful, initial problem, okay. We have two things. Pin 3 here is stuck. It's not working at all. So we're trying to solve that. Secondarily, the carriage is never homing, which it should. And assumption is that the pin should not be active when the carriage is homing. And we have two possibilities here. This being active is preventing this from happening, or there is some other potential relationship between these two problems or something. I don't know. There's no real way to know here that I can see so far. So I'm trying to go through and make sure that there's not something erroneously pulling this down. But so far it seems all correct. And this is very frustrating because it seems right. Wrong camera, you would be correct. All right, take it from the top. We have two problems. The pin on the solenoid for the print head is stuck. All right. But also the carriage motor that moves the head back and forth at 1.5 across R2 is probably not correct. I don't know what you mean. As in, it shouldn't be like that, or I messed up the measurement. Anyway, the other assumption is that the pin should not be stuck while this tries to rehome. There's two possibilities there. This being stuck is preventing this, and fixing this problem would make this one happy. Or two, we have two separate problems. I don't know. That 1.5 volt string on the stuck output. I'm confused. Why is this bad, but then this is completely acceptable? The pin is literally sticking out of the solenoid. We have traced it all the way back up to the character ROMs where we're seeing a low output from the buffered character ROM. Playful, the other thing you should know is that there's like 3 different revisions of this board in there. So it's not as easy as just finding it and then going and looking at it. I don't know how to designate which revision this is. This board didn't change? Wanna bet? Here's mine. 3, 2, 1. Here's not mine. 3, 2, 1. Or is this one mine? I don't know, but there's 2 of them. Something was different. I don't remember what it was. But the layouts at least were physically different. Maybe the schematic stayed the same, but the physical layout was different between the 2. So that one is mine. You can see all the transistors are all in a row and then one pokes down every now and then. And then here, they're grouped in pairs like that. Different revisions. Yeah. I am looking at pages 256, 275, 277, 284, and 292. Where's the N-prim high signal? I don't know. Just somewhere. Comes from J5. I don't understand. Why is it going to a connector? All the logic's on that board. Why does it go to a connector at all? Yeah, so I guess here's the latest thing I have not fully digested. We have 1.5 volts across the, I don't know, shunt transistor on the driver. Yeah, so it looks like it can never be disabled, is what it is. I agree, we definitely saw the NAND pull low. Yeah, let's go measure this one more time just to be sure. The buffered head enable. So D6 is right here. It would be this pin to ground. Let me go measure that one more time. Oh, I feel like I screwed that up last time. I don't know. Let's measure that one more time. Okay, D6 is under the 2 transistors. non-stripe side is right here. Maybe I did get this correct. Yeah, 0.1 volts. Stupid thought. What if that was shorted? What if D6 was shorted? No, that's useless. Microsoft Surface. We did all that this morning, nothing was shorted. That's why these were initially flagged as good, because nothing is shorted there. Check what it says on page 145 or 2. The symptoms we're seeing. No, that I have not seen anything about. I just went straight to the schematics. No print, space, but that logic board, loss of printable bit. E2510. Wait, what? Printable bit. E2510. Yes, Usagi, yeah. Top right. Did I miss it? Am I blind? I don't see E25. Page 290. Okay. Looks like it's a multi-element one. So there it's one part. I don't see pin 10. There it is. E plus. What on earth? That's part of the CPU. Should I just push it into a dumpster? Bit 8 of the... Yeah, that sounds a little more correct. So... How do you know which... So, Rev C. Okay, I see that in the lower right. Let me look at this. Is there a Rev here? Rev C. Is it possible that this is for the wrong Rev? Because... Yeah, we can't really consistently say what's what from that. I don't think we can search. Oh, we can search. Okay. That's literally the only instance of printable bit in the whole thing? $61.6 for M7728. Oh gosh, 7728. Okay, hold on here. This might be glossary. I'm kind of hating this thing. Character generator ROM. Dot matrix. So it should be here somewhere. 3311 or 61.6. Well, Hollencroft, it's also difficult to determine which information is for which revision. E52 pin 13. Oh. Right there, that one that says printable. Yeah, that. Okay, so that goes to you on J5. Where's J5 go? That's J1. It also loops back to this, which involves two other chips. And I don't know where that goes. Oh, MPC9. Which is the same sheet. I was going to complain that it was another friggin' stupid scam sponsor email, because I just get them all the time on my public-facing email address. Like, genuinely, it's almost becoming not worth it to have a public-facing email address, but that was someone with a genuine question. on a Discord server. Okay, but what does loss of printable bit mean? Where does it go? So 3311, was that this one? 52. No. 61. Okay. So here we go. 61.6. Destination. Oh my gosh, this is the net list. Okay. So page 4, whatever. Hold on. 9 was 9.2. Okay, let's see if this tracks in any kind of sensible way. Is this MPC 8? It is. So we need to go to 4. Right? 4 E14 1. Okay, what's E14? E14 is a MUX chip. Discord notifications muted. So Playful, oh, you're asking Q2, because I think you asked Q1 earlier. It's mounted to a heatsink. We can't remove it and test. I can trace it back, kind of, to where it goes, but it's a pain in the butt. If you haven't given it a character to print it all, this should be inert.
Chlorocoon says CHEER 200.
Discord notifications muted. Check. Phone put to the side. Check. Some of chat thrown out of window. Check by your command.
Thank you for the 200 bits, Chloe. All right, R4 voltage. Well, Playful, it's like an active live thing that I'm editing. I don't want to have to update it all the time. Like, I'm about to go write another one onto it. Genuine question, okay? Like, because this was a thing that was occurring to me, and for that use case, this would be actually kind of nice. Is there a site that allows uploading images and annotating them, and that's it? That's all you do. Maybe you can share it. maybe it works with cached local images. Is there something like that that people can think of? All of them are relative to ground unless I put 2 lines like that. Because I was half contemplating taking my Mario Kart world code and trying to modify it into something where you could upload an image that replaces the map background, basically, and then draw lines and put text on it for taking notes about stuff like this, and then adding layers like this for different things. Excalidraw. All your data is saved locally in your browser. Okay, I am genuinely curious. Is this something you guys have actually used, or did you just Google it and find it? Either way, I don't really care. I'm just curious. Let's say we take this and just... Well, so far, not impressed. I would love for it to be really good. But yeah, that's not... That's making like a worse mistake than all the PDF readers, unfortunately. Because this image is way higher res than that. Needed to be web-based, Poot. That was the thing. All right, R4. Fun fact, this thing is completely locked up. It's, yeah. It's holding power button to turn it off. There. I didn't pay attention to what R4 is. R4 is under Q2 on the left. Actually, you know what? Let's try a thing. 3 volts and dropping. .5 volts. Isn't the resistance supposed to increase with current or heat? So still dropping. I'm killing it so I don't roast the solenoid. .3 volt equal replace Q2. Q2 is probably dead. Man. Oh, wait. Now I'm back. Okay. Never mind. All right. So... What does this have to do with this, though? Or are we working off of the assumption that this will go away if this behaves normally? Nothing whatsoever. Delightful. So we have 3 problems? Global enable is off. It's not trying to send data. Why is this 5 volt? Oh, you're saying that this could just be garbage state on initialization? And that it doesn't matter? And it's a really horrible coincidence that it is also active? I don't know. I don't feel like that's going to be it. All right, it's time for some snacks. Okay. What am I snacking on? Hopefully 6531Bs. I bet I'm not going to get a good look at what the markings are. Okay, so they literally say it on it. Okay. How's that cool for a transistor? This transistor is labeled with color bands. Did you check all 6 voltage rails? I think we did. It sounds familiar. Starting to think I'm not going to have one in here. So, Sagi, I think we measured the voltage rails on all of the capacitors, and they looked really good, and they made up basically everything. I can't remember. I think negative 21 is the only thing that we couldn't have measured in what we checked, but everything else looked good. Kind of weirdo transistor is that one, man. Jelly bean NPN, so 2N222. I think I just found a 6551. That's either the model number or the production date. Transistors come in that package too, Sanity. Look up Darlington transistors. They usually come in TO220s. Oh my gosh, there's so many in here. Well, that one's roasted. I was thinking 51st week of 65. But I don't know. I'm not thinking too much right now. All right, let me go just find a 2N22, whatever. Is there somewhere where we can measure VREF? Because I can just do that before we try and desolder anything. Because I don't think it's going to be very fun. I mean, it wouldn't be just right there on the other side of D5. Okay, D5. That's not it. That's also not it. That one's it. Okay, D5, we want stripey side? Yeah, stripey side. Okay, measure that to ground. Ow! thing's got stripes all over it. One side's a bust though, so I'm gonna go with that. Okay, there's minus 21.
They've subscribed for 44 months, currently on a 44-month streak. And says your DECWriter is broke. I don't diagnose it for you. You're welcome, Colin.
End of line.
Thank you for the tier 1. And for 44 months. Hiram, thank you. Veer after grandeur show minus 21. It's not meaningless. It's what the manual says to do. I wasn't trying to indicate it was meaningless. You can always subtract the minus 21 to negative 21. I don't want to have to stand again. Where's negative 21? I'm going to have to stand again. Yeah. The bust side of R2 or R1. That's R1, isn't it? And R1's like big, so we could find that easy. Yep, there it is. So it's going to be this side. Okay. I didn't change it. Oh, I can just hit the button over here. Boop. Okay. Okay, that's minus 21, maybe, hopefully. 2.4. Oh, it holds for a while, too. Okay. So I'm pretty sure that's good based on what everyone was saying. So Q2 should just get yoinked and replaced with some garbage. Blech. I thought I had them in here. I don't. I moved them all to a different place. There. Yeah. Okay. I'm sorry about the buffering if it's my fault. Okay, welcome to Shelby's Transistor Emporium. Yay, woo! We got all the transistors you could ever want. We got this one, and that's it. That's all we got. All right, yay! Okay. So, it's like a magic trick. If I just, sleight of hand, just poof, then it'll be on there, right? The thing I don't like about attempting to do this is that there is a, like, fair rule or something around the base of Q2. That's gonna make this, like, a pain. Crop sensor zoom activate. That was the, like, Justice League, like, transition sound effect. Okay. Verify it's emitter collector base. We already looked at it earlier. Pretty sure it's, I mean, I don't know. It's whatever the normal one is. Okay, so yeah, that's the one right there. That's the one that's got to go. I think I can desolder it without removing the board, which would be really great because removing the board's gonna suck. Where's the transistor, the thing? Not transistor, tweezers, that's it. I just want to pull this up. Can I get to the pad? Really not easily. Yeah, that's gonna suck. Well, we'll see. Okay. Yeah, it would be prudent to validate that these are direct swap parts. I'm just gonna do that really quick here. Okay, I should be back now. The cable for the battery bank keeps unplugging. So I'm just gonna clip the mic onto my pocket and hope for the best. Okay. All right. Sorry for the clap. Logically illiterate. Hello and welcome. Thank you for the kind words about the videos. We are having a very fun time with this stream right now, trying to figure out how we're going to repair this thing. I personally really don't know if what I'm about to do is about to work or not, but we'll find out. 1, 2, 3, emitter base collector, okay.
Loracus FCHEER 200. Summon fire the audio guy. Microphone. They aren't doing their job.
End of line.
Oh, thank you for the data sheet link. Oh, you're all fancy, probably going for the right one that they actually used. Collector base emitter again. I just have it backwards. Okay. And then collector base emitter. Collector base emitter. Okay, yeah, they're direct swap. Yeah, yes. Fun. Yeah. This is like, what, day 5 of this? Maybe day 3 of earnestly working on it, but way more than I thought it would take. And frankly, when I gotta edit a video about this, I'm just gonna use the stream footage and I'm just gonna narrate over it, like, and then it was broken and then it wasn't. And you don't want to know how we got from point A to point B. Oh yeah, Chloe, thank you for the 200 bits. I didn't realize I didn't say it because of the mic problem, so I'm just throwing it off. Also, G-Pin earlier didn't actually say it, but I see it. Thank you for the 100 bits. All right. Let me finish my coffee, and then we'll go try and swap that transistor and see what happens. Ugh. And we fixed a single transistor. Magically, it started working. Yeah. Definitely. Yep, for sure. The ROMs definitely won't be bad after this. And then the... oh, come on. Great. Fun. I'll have to soak that when I get home. If I spill even the slightest bit onto the threads of the bottle when I go to put the lid on, then it like welds it shut and I can't remove it. So I'll have to pour hot water inside of the bottle and then fill a bowl with hot water and then put it in upside down to get it to actually release. Okay. Lisa, this fixes stuck solenoid. Do you feel better about powering it up with a head connection? That is genuinely gonna be a good thing. So you know what? Yes, that is a silver lining. We compare the spec sheets to see if it acts as a substitute. Let's see. 50. Wait, nanoamps? I don't know, 60 volts. Toggles at 5 probably. And then 40 volts, toggles at 6. It's probably fine. C2 and 222 for the specs? Are you serious? All right, let's go drop it in then. Oh, this is gonna be quite the challenge to solder. Bear with me for a moment while I get the iron within reach. Oh, this is 100% gonna fall. I'm doing totally normal things, don't worry about it. Definitely not using an air hose to hook onto a power cable so it can't fall behind my desk. Okay. All right. All right, 1 Metcal, 1 iron, 1 iron holder. Now let's get 1 power cable. Oh, look, there's one on the floor. I mean, organized exactly where it should be. Logically illiterate, I lease this location specifically for this. This is, and okay, this right angle's in like the worst possible way. But this is a location just for this. The YouTube videos are my job. Twitch streaming. Okay, here we go, power cable. Won't matter. Okay. That will reach to the stack of stuff. There we go. Beautiful. You guys ready for some totally not cursed soldering? All right, to the floor. Oh wait, you could. Yeah, you could see me. Okay.
Loriku says CHEER 200 not cursed. Unsubscribe.
End of line.
Unsubscribe, yeah. All right. Is it any worse than data general soldering? I don't know what the quality of the soldering is like. The only thing I know is that I don't want to remove the board. So, here we go. Let me grab tweezers. I'll be helpful here. All right, unfortunately I can't read chat right now. So just bear with me for a little bit here. Let's start out by tinning this. It has more thermal mass. And there's nothing I can really do about the third one. Okay, this is not going to be a left-hand iron job, that's for sure. I'm just going to walk it up little by little. Oh no, it feels like that leg might be folded over on the back. Yeah, that one moves. Stupid ferrule. There we go. That one might be topside. Okay, that leg is free. That leg is free. Okay. So now I'm going to do is I'm going to try and fold these flat to the case so I can push the ferrule up as much as possible so I can hopefully get to the pad. That I think will work. Boom. And to confirm, yeah, the legs weren't crossed over or anything weird. All right. I'm setting that transistor aside. Looking for where I put the new one. There it is. Okay. Putting the ferrule on the new one, but I'm going to have the legs be way wider because I'm not going to trim it. Let me put a little bit of fresh solder in this one because it did not get tinned. This is a not easy solder job. Stop bending. There we go. Stay right there. Okay. Come on. There we go. Okay. Did that pop out too much? Yes. Now it's in. All right. I'm going to leave it spider-legged like that. It's horrible, but then I know it's not like poking through too far because the legs are not trimmed. All right, I guess we turn it on and see what happens. Yeah, I wasn't trying not to go too far in for the flex ribbon. Yeah, I think that's it. All right, here we go. Pin is still firing. That changed nothing. All the traces it connects to are, I think, on the same side, but it doesn't matter. It didn't change anything. I replaced Q2 entirely. Turn it on if you've disconnected Q2. Why do you guys think I would? You just watched me put Q2 back in. Like, how many of you just like tuned out? Unsolder Q2, I mean, that's not a quick check. Like, the board's not going to really enjoy doing too much of this. I'm removing the collector and the emitter. I'm not removing the base. All right. Not holding. So loose. Yeah. I don't think we have any reason to assume Q2 is bad now. You realize, BK, that nothing down here is labeled, right? So when you say R5, it's not, I can't just like quickly go check it. Nothing here is labeled. I'm not saying I want directions for where it is. I'm just saying that it's not. And additionally, it would be more beneficial if you could say, can you check R5 to see if blank? This goes back to when we started the stream and I was saying having people giving me directions while I'm driving, which is just, turn left, turn right, is not useful. The pin was, I'm not, I'm going to, Jaco, I'm not telling you. No, I'm not telling you. If you weren't paying attention, that's your loss. Sorry, but my God. Oh, I got it. There we go. Okay, BK, I get that now. Thank you. I mean, couldn't we just check for shorts on the diodes? Wouldn't that be easier? I don't like powered tests. It sucks to do powered tests. So if there's a shorted diode, that would be better. If that's what you're suspecting. I would rather measure 4 diodes than measure 1 powered test. Oh, sorry, Ben. Well, for the whole soldering thing, I missed that. I missed all of chat while I was soldering. DMM doesn't have enough voltage to test properly. Okay. I am stating right now, up front, the curve tracer is not entering this room today. And no, I'm not taking the test subjects to it. Okay, well, okay, if we're concerned about the diodes being too high voltage to be able to properly test, okay, that makes sense to do the voltage check. Okay. All right. R5. Yeah, power tester goes to see sparks molten metal. Yeah, no. Not when it's something you want to actually work. Okay, there's R5. Playful. The sanity, I'm not ruling it out. Yeah, playful, I'm seeing that. Did we do that before? I would like to... Q2 was minus 22 before. We'll do two measurements here. We'll do R5 across. Boom. And then we'll do Q2 to ground. We can do both. Hiram, you've missed a lot, it seems. Base of Q2 equals R5. So what you're saying is this is the many people maps problem again. Okay. Just... like, no offense, everyone. I really do appreciate the help. It's just... it is difficult being the singular bottleneck to everyone's diagnostic steps. That is the problem here. I really do appreciate the help. Genuinely, I don't know. I would have put this thing away and then probably never gotten back to it by now. On my own. I also don't know if we're really making any legitimate progress, though. So far, it doesn't seem like it. All right, Q2 with transistor pulled. Legs are floating. Same, negative 21. Unless that's whatever VREF nonsense is offset. So 21.5. Okay. R5. .4 and falling. I think it was 21.5 for Q2's base with it lifted. So not really any different. Saying it should be 0. Okay, so one of... Wait, you're saying one of the weird shunt diodes is bad? So, Poot. 1 is collector, and here, collect. There's a very good catch there, Poot. It sounds like that may not have mattered, though. Well, Usagi, there's some other test that we did where this one, R5, was getting a voltage when it shouldn't, and supposedly that would lead to these, one of them being bad. I don't understand it at all. That's PK's theory here. Oh, 6531B being different's a good call, too. Hold on. I don't know if I can find the B variant. Although Hellencroft found this is like the Fairchild one. I don't know if... I don't know. And Playful, I remember everyone asking just about every possible thing, so it's... All right. Zener diode I can only test with a curve tracer. I'm holding firm to I'm not bringing it in here today. So we might be done on that. BK is saying we could test against R6 to rule it out. What would that? Where is that? R6. I don't see R6. Oh, there's R6. I'm blind. Whee. Okay. Majenko, that's part of why I was asking about the web schematic viewer thing, because having it be editable, well, not necessarily editable, but viewable by everyone would be very beneficial, and viewable live. I feel like there's probably some really expensive education software that can do it. That you have to pay $1,000 a month subscription per seat. But yeah, I just want some open source nonsense. Staring contest. No, it's more just thinking. I wouldn't call it trivial, Ben. I feel like there's like a 30% chance every time I do it, I'm going to cut myself. No, I don't have a cheap parts tester. I have a curve tracer. I'm not saying I don't want to curve trace the diodes. I'm saying I'm not touching it today. Oh, that's good find, Helen Croft. You know, I could have told you that, actually. Because it's printed out on the one I removed, now that I think about it. No, it's not. Okay. That was a good find. Oh. So, emitter-based collector, I think that is opposite of a 2 collector-based emitter, yeah. So that was backwards. All right, BK, I'll go measure R6. I don't understand any of what we're getting out of this. I'm not necessarily asking you to explain. It's just, you seem to have a thought process here, so I'm going to measure that, but I am completely out of ideas at this point. I gotta get where Usagi's coming from with looking at the carriage. I don't know. I was just focusing on the thing that seemed to be the most dangerous first, to try and get it into a savable or usable state. That was why I went with that first. All right. Where's R6? Okay. I feel like I've already done this, but I don't think I did it with the transistor off, so this is a slightly new test. How is it so hard to clip onto chunky through-hole parts? Let's go on to Q2 for one side, because I can't reach. I can't get it to stay on. All right, here we go. It's 0. Actually, I'm not sure that that made reasonable connection. Yeah, it's 0. Okay, so R6 is 0. Things are initializing correctly. The remaining stuff could all be in manner of chaos. I ended up thinking, I feel like it's being slightly unfair to me because we don't know that the head isn't initializing because the pins are erroneously high. Unless I missed something. No, I'm not checking the transistor shortage. I'm sorry. I think I'm done. I don't know. I don't think there's anything else I want to do today. I don't know. I want to form an actual plan for tomorrow. Yeah, Q2 being backwards is not a good test, yes. I think I could flip Q2 reasonably easily. Let's just do it. I have this thing. I really hate puzzles. I hate the idea of escape rooms too, because the way my brain works, it just is not good with puzzles like this, where it could be any number of things, because I am just not good at deciding where to start or eliminating things. So I find this kind of thing very taxing. Yeah, boy, did I pick the wrong fields to go into with that problem, didn't I? Some problems with a single symptom, it's a little easier to work backwards from or figure out what's going on. And with knowledge, you can make some more educated guesses. I do not have the knowledge for this. So my guesses all suck and are worthless. All right, there it is. In the other way. All right. I have this irrational thought that I want something between me and this right now. Okay. Pin still grabbing. I assume it's D1 through D4 down here, right? Oh, none of them are super ultra shorted. I think we're done for today. I think I'm calling it. I think tomorrow before stream, I'm going to put the original transistor back in because I don't see any reason to leave that one in there. That one has been potentially subjected to naughtiness. What do you mean just take the new one out? Yeah, we're leave the heads disconnected, troubleshoot the other stuff. I mean, I'm just going to unplug the heads. I just want to put the other one back in. I don't want it floating around. I want it put back where it goes. So it is progress. I really don't feel like we have made any progress today, personally. I think we made 0, but I don't know. So I am managed to get it to release that pin. I mean, getting it to release the pin by breaking the whole circuit that controls it, I don't feel like it was that much progress, especially when it looked like we had upstream stuff that was also behaving weird. So I don't know. But all right, it's outro time. All right. I am definitely in the regret stage buying this thing. This is way more of a pain in the butt and far more broken than I thought it would be. And I don't even think they go for that much money. So like just buying one that worked, honestly, I mean, I got it for like 10% off, but it's been way more than 90% in a headache. So I don't know, but yeah. We will look at this more again tomorrow. I am not guaranteeing that we will continue looking at what we have been looking at already. We might start looking at the what you call it? Oh yeah, new video on TT2, sure. Yeah, that's not a bad idea. I was about to completely forget that, probably for the rest of the day. Let's see. Edit. Public. And save. Alright, there you go. There's a new video on the TT2 channel that you can watch. It's an hour long, but it's really only 20 minutes. Actually, it's more like 30 minutes, but yeah. Anyway. Yeah. So we'll see. Anyway, if you enjoyed this stream, you may want to follow to be notified when I go live again next. If you want to help support the channel, you can find me on Patreon. That's it for now, and I'll see you next time.